You know that phone in your pocket, the car you drive, the coffee you had this morning? There's a really good chance that all of it started its journey to you from the middle of a wild, chaotic ocean. So how does all that stuff get to you? Well, it's not magic. It's some of the most incredible large-scale engineering on the entire planet. Let's dive in.
Okay, so it all starts with this one huge question. The ocean doesn't play nice. It's a place of just immense, unpredictable power. So how in the world do you build a massive structure of steel and concrete that can actually survive out there, let alone operate day in and day out? That's the billion-dollar question engineers have been figuring out for a long, long time.
All right, so our story begins right where the sea meets the shore, at these massive gateways that connect our world of commerce to the vast open ocean. We're talking about harbors and ports.
At its heart, a harbor is basically a safe house for ships. And this isn't a new idea, right? For as long as we've been sailing, sailors have looked for these natural shelters to hide from storms, fix their ships, or just get some rest. It's a safe haven. It's as simple as that.
Okay, so you hear the words harbor and port all the time. What's the actual difference? Well, it's a really important one. Think of it this way. The harbor is the calm, sheltered water. The port? That's all the stuff we build around it. The piers, the giant cranes, the warehouses, the train tracks, that's the port. It's the engine of trade that's built inside the safety of the harbor.
But here's the thing. Nature doesn't always give you a perfect, calm little bay to work with. So what do? Well, you build one. And that means you've got to figure out how to actually tame the ocean itself.
And the number one tool for that job is the breakwater. We're talking about these absolutely gigantic barriers, basically man-made coastlines. They're engineered for one single purpose, to smash the energy of storm waves and create a pocket of calm water behind them. Honestly, without these, most of the ports we depend on just couldn't exist, period.
So when it comes to stopping a wave, you've basically got two main strategies. The first is a rubble mound. It's kind of like building your own artificial beach that makes waves break and lose all their power. The other way, you build a giant wall, like a cliff, that just reflects all that raw energy right back out to sea.
Now, you might look at a rubble mound and think it's just a big pile of rocks, right? But it is so much more than that. It's a super precisely engineered structure. And you can see here the ocean is just constantly attacking it from every angle, chewing away at the bottom, trying to suck out the materials from the inside, and just ripping at the surface.
So how do you fight back? Well, this is where the engineering gets really clever. Instead of just dumping a bunch of boring concrete blocks, they came up with these incredible interlocking shapes. Things like dolos and tetrapods. Think of them like a giant, super strong 3D jigsaw puzzle. They all lock together to create this amazing shield that's tough enough to handle the waves.
Okay, so we've got calm water. Awesome. But now we have a new problem. We need a place for the ships to actually dock. We have to, build solid ground on top of water.
And it all starts with the foundation. But you can't just pour concrete into the water, right? It would just wash away. You need to anchor everything to the seabed. And the way you do that is by driving these massive columns, they're called piles, deep, deep into the ocean floor. It's really like hammering giant nails into the planet to hold up the whole port.
This whole thing happens in 3 basic steps. First, you've got pitching. That's where you lift the pile and get it standing up perfectly straight. Then comes the fun part, driving. A massive hammer just slams it into the ground. And finally, staying, where you connect all those piles together so they become one solid, stable structure. And this is the beast that does all the work. It's called a pile driver. You see, there's a crane that holds the pile perfectly straight inside that frame, and then that huge hammer at the top just bam, 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 drives it all the way down through water and mud until it hits solid ground.
And this picture really gives you a sense of scale, right? That first step, the pitching, is just wild. You're lifting a giant multi-ton beam of concrete or steel, flipping it upright, and trying to place it in the exact right spot, all while you're floating. The precision required is just incredible.
But even once the piles are in the ground, they're not done. You've still got tides and currents constantly trying to push them around. So before they build the main deck on top, they install this temporary bracing system, that's the staying, to lock everything together. It turns all those individual posts into one super rigid grid that isn't going anywhere.
All right, so we've got calm water and we've got a foundation. We're all set, right? Well, not quite. There's another potential problem. The water in our brand new harbor might be too shallow, and that means we literally have to start redesigning the ocean floor.
And why is that a problem? Well, have you seen the size of a modern container ship? They are absolutely gargantuan. We're talking 4 football fields long. And these behemoths need incredibly deep water just to float, never mind maneuver. Most coastlines are nowhere near that deep naturally, so we've got to dig.
The tech for doing this is called dredging, and it's got a surprisingly long history. I mean, Leonardo da Vinci himself was sketching up ideas for this back in the 1500s. Fast forward a bit, you get steam power, but the real game changer was suction, which led to the machines we have today. And they are just mind-bogglingly powerful. We're talking about moving enough sand and silt to fill 4 Olympic swimming pools every single hour. Just think about that.
And this is what one of those monsters looks like in action. It's basically a gigantic floating vacuum cleaner. It just sucks up tons of material from the seabed. It can either hold onto it or, like you see here, shoot it out somewhere else to build up land. It's underwater construction on a scale that's hard to even imagine.
Okay, let's recap. We've tamed the waves, built the docks, dug the channels, our port is ready. But it's all completely useless if we can't get the goods off the ships and onto land. We need that final, crucial connection.
You see, a port is basically an island until you connect it to the road network. And that connection is pavement. But we're not talking about the road in front of your house. We're talking about a surface that gets absolutely hammered by thousands of super heavy trucks day in and day out, 24/7. It has to be incredibly tough. So for these extreme traffic zones, a go-to solution is something called white topping. It's a special kind of super tough concrete, and the reasons are pretty clear. First off, it's insanely durable. It can last for 20, 25 years with barely any maintenance. Plus, it's safer because it reflects light better at night. It even saves fuel for the trucks, which is good for business and the air. And get this, it helps keep the area cooler in the summer. It's just a win-win-win.
So there you have it, from building artificial coastlines with giant concrete puzzles, to hammering foundations into the ocean floor, to paving roads that can take a beating for decades. It's this whole invisible chain of incredible engineering that really makes our modern world tick. It really makes you wonder, right? With ships getting even bigger, what's next? Are we going to see entire floating cities out at sea, or maybe ports run completely by robots? The crazy ideas of tomorrow are already on the drawing board today.